Hey guys, so today we're starting with tasty integrals. If you're interested in math and you want to learn more, don't forget to hit subscribe and like my video. So let's just get started. All right, guys, so we're starting with 8 integral questions, and we're just going to integrate these 8 unintegrated expressions. So let's just start with the first one. So x cubed plus 1. First of all, we should know how to integrate. So guys, if we have something after this integral symbol, which actually refers to sum, is actually the sum of the area under the slope. So basically, we're calculating an area under a slope, but this is an indefinite integral. An indefinite integral means that there's no bounds of this integration. So what we're gonna do is we're gonna increase the exponent by 1 and divide by the last number of that integral, that exponent, I'm sorry. So in this case, if we increase our exponent by 1, we're gonna get x to the power of 4 divided by 4, because 4 is our last exponent. Plus, since this is a constant, we're just gonna plug the variable, which is in this case x, because of dx. So we're gonna do x, and since this is the power of 1, because imagine guys, this is the power of 0, so it's 1 times the something x to the power of 0. So if we increase the power by 1, we're gonna get x divided by 1, which is actually x. And also guys, if we're dealing with indefinite integrals in this case, like this, we're adding a c, which is our constant value. We have to add c's. And guys, there's no such thing as 2c's or 3c's. We just say c. So if we add two integrals, like let's say x squared divided by 2 something, and it has c, this is, let's say this is a separate integral, we're not adding these c's, guys. This is not like some kind of variable. This is just a c is representing a constant value. So this will be our integral integrated version of this. Okay. B. Oh, so guys, we have some weird things. Since we're multiplying this, there's actually two ways. We can either multiply this, or we can also use our u substitution. But however, in this case, if we use u substitution, this won't cancel out any terms, because we use u substitution in order to get rid of some other variables and make it more simpler so we can integrate it. So in this case, what I'm gonna do is I'm just gonna distribute this radical x inside to this parentheses. So I'm just gonna end up with integral square root of x minus square root of x times x squared. So guys, first of all, just make sure you know that square root of x is equal to x to the 1/2 power. So if I'm multiplying two exponent expressions, I just can add the exponents together. So in this case, if this is, let me just erase it, x to the 1/2 power, and I'm multiplying with x to the second power, what I'm gonna end up is actually x to the 5/2, because I'm adding this 2 to this fraction. So minus the square root of x integral. So this is actually my simplest form. Yeah, dx over here. All right, let me just draw a line over here so it could be more comprehensive. All right, guys, so after this part, we're doing the same thing. So this is x to the 1/2 power minus x to the 5/2 integral dx. So I'm just going to increase my exponent by 1 in both cases. So I'm just going to end up with x to the 3/2 minus x to the 7/2. Also, I'm gonna divide this by 3/2, which is actually multiplying it with 2 times 2 over 3, and also the same thing over here, 2 over 7. I'm multiplying it, and also don't forget your plus c, and you're done, guys. So what I did is just, it might look quite complicated, but actually it's not. I just make this integral more simpler by using exponential fractions, and after that I just increased my exponent by 1 and I just divided it. So there's nothing complicated in this case, so just don't worry, guys. Question number C. So guys, this question is actually one of the greatest questions on this worksheet, so I would strongly suggest you to listen this carefully. So integrate cosine square x sine cube x dx. So guys, notice that there are many functions, so it's hard to integrate, right? We can't integrate something like this, so I'm just using my u substitution. Let's say that u equals to cosine of x. Also, let's say u square is equal to cosine square x, since I have a cosine square x. Cosine square x. Also, what is cosine square x also equal to? Cosine square x plus sine square x is equal to 1 from trigonometry. This is a formula. And after that, since cosine square x, we're trying to find for cosine square x, cosine square x is equal to 1 minus sine square x. 1 minus sine square x. So actually, u square is equal to 1 minus sine square x. And I also want to solve for sine square x because I have a sine square over there. Even though it's a sine cubed, I can just pull out my sine square. And that will be sine square x is equal to 1 minus u square. Very good. Ultimately, I want to find my derivative. So it's going to be du dx is equal to negative sine x, because when we take the derivative of cosine of x, it's negative sine of x. So after this part, we should be able to know everything. Also, I want to find my du. Since I have a dx, and also I'm going to have a sine x over there when I pull out my sine square. So it means that du is equal to negative sine x dx. Okay, let me just write this down. Integrate cosine square x sine square x times sine x times dx. So guys, I have my sine square x, which is 1 minus u square. I have my cosine square x, which is my u square, and sine x dx is actually negative du, because if I multiply this with negative 1, I'm gonna get negative du. So let's just write this down in terms of u. U square times 1 minus u square times negative du. Now let's just distribute this u square. U squared integrate u square minus u to the 4th power times negative du. So I just want to multiply with negative 1 to get rid of, so I'm just going to multiply this negative 1 over here. So I'm just going to end up with negative u square minus, actually plus u to the 4th power times du. Now we're simply just integrating it. So after this part, it's going to be negative u to the 3rd power divided by 3 plus u to the 5th power divided by 5 plus c. And after that, what was our u, guys? Our u was over here, cosine x. So cosine x to the 3rd power over 3 negative. Don't forget your negative. Actually, let me just write it over here so it wouldn't get mixed. Cosine cube, negative cosine cube x over 3 plus cosine to the 5th power, or x over 5 plus c. Don't forget your c, guys. So the integral of this will be equal to this. Yeah. Question D. Integrate tangent x secant x dx. So guys, first of all, I just want to write this tangent x as sine x over cosine x times 1 over cosine x dx integrate. So this is actually integration of sine x over cosine square x dx. Sweet. So guys, usually in these cases, we use our denominator as our u, because we still have to use our u. And I'm gonna say u is equal to cosine of x. okay? And du dx is equal to negative sine x, since I'm deriving cosine, and it's going to end up being negative sine. And if I want to solve for dx, because I'm gonna plug for dx in this case, unlike the other one, I'm gonna end up with x is equal to du over negative sine x. Basic algebra. After that, let's just write everything in terms of our new variables and integrate sine x over u square times du over negative sine x. So these just sines x goes away and there's a negative sign. I'm just gonna make this positive. I might put my negative sign outside of my integration symbol. And what I end up with is negative integrate 1 over u square du. Actually, this is also integration, negative integration of u to the negative 2 power minus 2 power du. And after that, we're just increasing our exponent by 1, which is going to be u to the negative 1 power, and also divide with your new exponent, which is negative 1. Also, there is a negative 1 sign outside there, so you should multiply with your negative 1. And also, ultimately, don't forget your c. So what was our u, guys? Our u was cosine x, so I'm just going to make this look prettier. This is actually u to the negative first power. This negative ones multiplying ends up being positive ones. So this is actually u to the negative 1 power plus c. And u to the negative 1 is actually just writing 1 over u, which is 1 over u plus c. And my u was cosine x. So it's going to be 1 over cosine x plus c. Great. Question number 5, guys. So, integral 1 over radical 1 minus x squared. So, guys, actually, some of you might try to solve this integral, but actually, it's the arc-sin function, because if we take the derivative of arc-sin function, we're going to end up with 1 over square root of 1x squared. So if we integrate this, we're just going to get the same function, arc-sin x plus also your c, dx over cosine square x. So guys, over here, we can just write this as 1 over cosine square x dx. And after that, we know that 1 over cosine is actually equal to secant x. So I just can write this as secant square x dx. And you all know that secant square x, if we integrate this, we're going to end up with tangent x plus c. And this will be our last 2 questions, guys. So over here, secant square x over radical tangent x. So what we can do over here is, I just want to call my secant square x, my tangent x, I'm sorry, tangent x is equal to u, because if I take the derivative of tangent x, I'm going to get secant square x, which will be helpful to solve me for this integral. So du dx is going to be equal to secant square x. All right. And my dx will be equal to du over secant square x. So some of you might already see that. Now we're gonna cancel out those secant squares. Let me just explain it to you. So integrate secant square x du over secant x divided by radical u, because my tangent was my u, And now I'm going to cancel out my secant square x's and integrate 1, actually 1 over radical u du. And over here, I just can write this as u to the -1/2 power, since this is the radical sign over here, and this is under the 1 fraction, so this will be, I'm able to write this as u to the -1/2 power du. And after this, you're just gonna integrate it, and when you integrate it, you're just gonna add 1 to the exponent and divide with your new exponent, so it's gonna be u to the 1/2 power, since 1 plus -1/2 is 1/2, divided by 1/2. So if you divide by 1/2, you're actually multiplying with 2, so we end up with u, or 2u to the 1/2 plus c. Now, what was our u, guys? Again, 2 times our u was tangent x, so tangent x to the 1/2 power plus c. And here is our last question. Integral e to the x plus 3. So if we're integrating e to the x just integrates as e to the x, nothing else. And 3, since we're integrating in terms of x, we're just going to multiply with x, 3x. Also, your plus c. Guys, if you're not sure if your integration if your integration is not too complicated, because some integrals are very complicated, you just can try to take the derivative. So if I try to take the derivative, just don't see the c because we're not messing with c. What I would get is, if I integrate e to the x, I would get e to the x. And if I integrate 3x, I'm just going to get 3. So this will be my I'm sorry, if I took the derivative, this would be my dx. So if I dy dx, okay, so it's actually the same over here. So if I am able to get the same thing when I derive it after I find my integral, that means that I did something right and there's no mistakes. So make sure you know that, guys. I know that some of these integrals are very hard and it is quite impossible to solve. So I did my best, and if you're struggling to understand, you just can write down in the comments. It will be a pleasure for me to help you out. Also, if you want to support my work, like and subscribe. Thank you for watching. Have a good day.